I am R.P. Tripathi, Professor Mathematics from AKtU Sultanpur. The topic of my lecture is triple integrals. Triple integral introduction. Let f(x,y,z) be a continuous function defined in a closed and bounded region V in 3-dimensional space. Divide region V into small elementary parallelepiped by drawing the number of steps. Let the total number of complete parallelepiped which lie inside the region V be n. Let del Vr with the volume of the rth parallelepiped and xr, yr, zr be any point in this parallelepiped. Consider the sum S is equal to summation n is equal to 1 to n, r is equal to 1 to n, f xr, yr, zr del Vr, where Vr is equal to del xr into del yr into del zr. If the number of elementary parallelepiped be n increases, then volume of each parallelepiped decreases. If n tends to infinity, del Vr tends to 0. The limit of the sum, if exists, is called the triple integral of f x y z over the region V and is denoted by triple integral over V f x y z dV. Hence, the triple integral V f x y z dV is equal to summation n is equal to 1 to n, r is equal to 1 to n, f xr, yr, zr dV dr del V del r. As n tends to infinity, del Vr tends to 0, where dV is equal to dx dy dz. How we find triple integral in Cartesian coordinates? Triple integral of a coordinate of a continuous function f x y z over a region V can be calculated by 3 successive integrations. Let the region V be bounded below by the surface z is equal to z1 xy and above by the surface z is equal to z2 xy. Let the projection of the region V in xy plane be R, which is bounded by the curves y is equal to y1x, y is equal to y2x and x is equal to a, x is equal to b. Then the triple integral is defined as I is equal to integral over a to b, second integral y1 x to y2 x and third integral z1 xy, z2 xy, fxy z dy dx. First we integrate the most variable. If z contains 2 variable, then we integrate first with respect to z. Y contains 1 variable, we integrate second, and x having constant limit, then we integrate with respect to x at last and we will get the result. Evaluate example 1 for triple integral. Evaluate integral over triple integral limit 0 to 1, 0 to 2, 0 to e, dy, dx and dz. Either we take limit from right side or left side. Solution: how we integrate the triple integral? Integral over 0 to 1, 0 to 2, 0 to e, dy, dx, dz. First we integrate the inner limit, means first we integrate with respect to y, means integrate with respect to dy, integral of dy is y and y varying from 0 to 0 to e, we will get e constant, take outside, again we integrate with respect to x, again we integrate with respect to x, we get x, x varying from 0 to 2, 2 is constant, take outside from the integral, we have 0 to 1 dz, and z is again integrated, we get z, and limit, putting limit, we get z is equal to 1, means 2 into e, it is the required answer of the given given integral, given triple integral. Example 2, evaluate triple integral 0 to 1, 0 to 1 minus x, 0 to 1 minus x minus y, 1 by x plus y plus z plus 1 whole cube dx dy dz, dx dy dz. Since it is the limit of variable limit containing two variables x and y, means it is the limit of z, z varying from 0 to 1 minus x plus y, it is the limit of x, upper limit containing x, hence it is the limit of y, y varying from 0 to 1 minus x, and it is constant, means it is automatically limit of x, and x varying from 0 to 1. Since z contains two variables, hence we integrate with respect to z first. After that we integrate with respect to y second, and at last we integrate with respect to x. Means first we have this, it is the question, first we integrate with respect to z, means this, we integrate, means keeping x y constant, the integral of this with respect to z is this, limit varying from z varying from 0 to 1 minus x minus y, substituting z is this, we get 1 minus 1 by minus 2 x plus y plus z plus 1 whole square, substituting limit, putting limit, we get 1 by x plus y plus z is replaced by this upper limit minus lower limit putting 0, means z becomes 0, means 1 by x plus y plus 1 whole square. We get, after solving, we get 1 by 4, this and this cancelled out, x and minus x cancelled out, y and y minus y cancelled out, we get 1 here, 1 and 1, 1 plus 1 2, 2 is square, means 4, 1 by 4 minus this. Since y contains variable limit, we integrate with respect to x, means 1 we integrate this with respect to y, 1 by 4 constant, we integrate with respect to y, we get y by 4, we again integrate this 1 by x plus y plus 1 whole square, we get x 1 by x plus y plus 1, limit is 0 to x, substituting y in place of x, y, substituting y is equal to 1 minus x in this equation, in this bracket containing y, we get 1 minus x by 4, 1 by 2 and 1 minus x plus 1. It is the after integrating with respect to z and with respect to y, we get this. This means 1 minus x by 4 plus 1 by 2 minus 1 by 1 minus x plus 1. We integrate at last with respect to x, we get minus 1 by 2 x by 4 x square by 8 plus x by 2 minus 1 plus log x plus 1, substituting limit x varying from 0 to 1, upper limit put x is equal to 1, we get 1 by 4, it is minus 1 by 8, it is 1 by 2 minus log 2 here. If we put lower limit 0, it vanishes and log 1 is again 0, means after simplifying we get the integral is minus 1 by 2 5 by 8 minus log 2. It will be the solution of the given triple integral. Third example, evaluate triple integral x square yz dx dy dz over the region bounded by the planes x is equal to 0, y is equal to 0, z is equal to 0 and x plus y plus z is equal to 1. Solution, how we find the integral of this with respect to x, y and z. It is x, it is 3 dimension, it is y axis, it is x axis, means it will be, it is the plane x plus y plus z is equal to 1. It is y is equal to 0, it is x is equal to 0 and it is z, it is y is equal to 0 and it is z axis, means first how you find the limit of this, how we find since the lower limit is x plus x is equal to 0, y is equal to 0, z is equal to 0, means all lower limits of x, y, z are 0. Upper limit is the upper surface of the plane, upper surface of the plane is x plus y plus z is equal to 1. Find the value of z, we get 1 minus x minus y, it is the upper limit of z. Since upper x plus y plus z is equal to 1, means z is equal to 1 minus z is equal to 1 minus x minus y, z is equal to 1 minus x minus y, it is the upper limit of z, means upper limit of z is 0 is equal to upper limit of z. We remove z here, we remove z here, z x plus y plus z is equal to 1, we remove y z because we have already chosen the limit of z, we get x plus y is equal to 1, x plus y is equal to 1, the value of y is 1 minus x, means upper limit of y is 1 minus x, means upper limit of y is equal to 1 minus x. Again x plus y is equal to 1, means we have taken the limit of z, limit of y, means we remove y, we get upper limit of x is 1, means upper limit of x is 1, means the limit of integration is x varying from 0 to 1, y varying from 0 to 1 minus x, z varying from 1 minus x minus y, this means x square y z dx dy dz. Since z containing 2 variables, we integrate first with respect to z, this means z dz, this. The integral of z is z square by 2, limit is 0 to 1 minus x minus y, this. Substituting limit, upper limit and lower limit becomes 0 because z is 0, here z 0 square means 0, upper limit is x square y, z means 1 minus x minus y whole square, this. Since y contains one variable 1 minus x, we integrate with respect to y in the second time and we get y square, x take outside, y 1 minus x square plus y square minus 2 y 1 minus x dy. Integrating, we get solving it we get this. Integrating with respect to y, we get 1 by 2 limit 0 to 1 x square 1 minus x square y square by 2 plus y raised power 4 by 4 minus 2 i's 1 minus x y cube by 3, limit of y is varying from 0 to 1 minus x. Substituting y is equal to 1 minus x, 1 minus x, 1 minus x raised power 4 by 4 minus 2 1 minus x y cube. Y cube means 1 minus whole cube this. Putting 0, it is 0, it is 0 and it is 0 means lower limit vanishes. After solving we get x square 1 minus x raised power 4 by 12 dx. We again integrate with respect to x because x keeping a constant limit, at last we have to integrate with respect to x. We get this substituting the upper and lower limit. Upper limit vanishes because 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, lower limit 1 by 5, 1 raised power 5 means 1, 1 raised power 6 means 1, 1 raised power 7 means 1, and calculating we get 0, upper limit 0 and lower limit is 1 minus 1 by 105. After calculating we get 1 by 2520. Evaluate triple integral dx, dy, dz evaluate triple integral x plus y plus z dx, dy, dz over the tetrahedron bounded by the planes x is equal to 0, y is equal to 0 and x plus y plus z is equal to 1. We have followed the same condition as the previous question for finding the limit of the integration. X is equal to 0, y is equal to 0 and z is equal to 0. X is equal to 0, y is equal to 0 and here it is z is equal to 0 and the plane is this. See here x is equal to 0, y is equal to 0, x is equal to 0, y is equal to 0 and z is equal to 0 with the lower limit. Upper limit is obtained since x plus y plus z is equal to 1. Find the value of z. Find the value of z. We get 1 minus x minus y. It is the upper limit of z. It is the upper limit of z means x is equal to 0, y is equal to 0, z is equal to 0 means the lower limit of x is 0, y is 0, z is 0. Upper limit is obtained by the surface of the plane means x plus y plus z is equal to 1 means find the value of z. It is the find the value of z. Z means 1 minus x minus y means it is the upper limit of z. It is the upper limit of z means the upper limit of z means 1 minus x minus y. This 1 minus x minus y. We have completed the limit of z. For finding the upper limit of y, we remove z because we have already obtained the limit of z. Find the value of y means 1 minus x. It is the limit of x y. It is the limit of y means the limit of y, upper limit of y is 1 minus x. Again we remove y, we get x is equal to 1. It is the limit of x means first we find the limit with the given condition with the given surface. Upper limit of x is 1, upper limit of y is 1 minus x, upper limit of z is 1 minus x minus y. Means first we integrate, since z containing two variables, we integrate with respect to z first. X y constant, first we integrate with respect to z, x y constant, dz means integral of dz is z and the integral of z is z square by 2. Substituting upper limit and lower limit, lower limit vanishes due to z, upper limit is z means 1 minus x minus y, it is 1 minus x minus y whole square by 2. X minus, again integrate with respect to y because y contains one variable 1 minus x. It is x plus y minus x plus y square 1 minus x minus y whole square by 2 dy. Integrate with respect to y, we get x y, it is y square by 2, it is x plus y whole cube by 3, it is minus 1 minus x minus y whole cube by 6. Substituting limit of upper limit of y is 1 minus x, lower limit of y is 0. We get 1, we get x 1 minus x plus 1 minus x square by 2 minus 1 by 3 plus x cube by 3 plus 1 minus x whole cube by 6. At last we integrate with respect to x, we get x square by 2, x cube by 3, 1 minus x raised power 1 minus x raised power this x by 3, x raised power 4 by x raised power 4 by 12, 1 minus x raised power 4 by 24. It is cube, sorry, it is cube. 1 minus x, it is not 6, but it is, sorry, it is 1 minus x cube by 6. Substituting upper and lower limit, we get, and solving, we get 1 by 2 minus 1 by 3 minus 1 by 3 minus 1 by 2 minus 1 by 3 minus 1 by 3, 1 by 12, 1 by 6, 1 by 24. Calculating this, we will get 1 by 8 is the solution. Example 1, we want to again repeat. Example 1, the limit of integration is 0 to 1, y is 0 to 2, z is 0 to e, dy, dx and dz. Solution, d integral over, first we integrate, either we take inside limit, inside or outside, means first we integrate with respect to z, again with respect to x, and at last with respect to y, and so on. Means first we integrate with respect to y, it is the limit of y, it is the limit of y, it is the limit of x, and it is the limit of z. Means first we integrate with respect to y, we get dy integrated y with respect to x, with respect to y we get y varying from 0 to e, upper limit is e, e is constant, take outside from the integral, we get 0 to 2 e, x is again integrated, we get x 0 to 2, 2 is again constant, take outside, and we get 2 e 0 to 1 dz is equal to twice e. It will be the result of first question, first example. Example 2, evaluate this. Limit is given, and limit is given, we find, we directly integrate. In case of a triple integral, first we integrate with respect to z, since z containing z, since it is the limit of, it is 0 to 1 minus x minus y, it is 0 to 1 minus x, and it is 0 to 1. It contains x and y, means it is the limit of z. It contains it contains 1 minus x, means it is the limit of y, and it is constant, means at last it is the limit of x. First we integrate with respect to z, means keeping x y constant, integrating with respect to z, we get 1 by x plus y plus z plus 1 whole cube dz, means it is 1 by, integrating it we get 1 minus 1 by minus 2 x plus y plus z plus 1 whole square, limit is 0 to 1 minus x minus y. Upper limit, substituting upper limit, we get 1 minus 1 by 2 x plus y, z is replaced by this 1 minus x minus y plus 1, lower limit it is 0, means we get x plus y plus 1 whole square. It is solving it, we get it is x and x cancelled out, y and y cancelled out, we get 1 here and 1, 1 plus 1 2, means 2 square means 4, 1 by 4 minus 1 by x plus y plus 1 whole square. Again integrate with respect to y, because y contains one variable x, the integral of 1 by 4 is y by 4, the integral of 1 by x plus y plus 1 whole square is minus and minus plus 1 by this. Again substituting the limit, we get 1 minus x by 4 plus 1 by 2 minus 1 plus x dx. Integrating it, we get 1 by x by 4, integrating it, we get x by 4, x square by 8 plus x by 2 minus log 1 plus x or x plus 1. Substituting upper limit, lower limit vanishes, because it is 0, it is 0, it is 0 and it is 1, means log 1, log 1 is again 0. Lower limit 1 by 4, 1 minus 1 by 8, 1 by 2 minus it is minus log 2, means we will get this result. Third example, it is a triple integral. We follow since it is triple integral x square plus y square, x square y z dx dy dz over region bounded. We have already discussed, means how to find the upper limit. First we integrate, z contains two variables, first we integrate with respect to x, again we integrate with respect to y, and at last we integrate with respect to z. Fourth example, we have follow the same procedure, means lower limit 0, upper limit is obtained by find the value of z, we get the upper limit, again we remove z, x and y, we get the limit of y, and at last we get the limit of z, integrating with respect to z, y and x, and we will get the result. It is the result of this 1 minus integrating with respect to z, with respect to y, and at last with respect to x, Thank you.